Good day, dear friends. Hope you are all fine. This is Pranashish back here to tell you how to get the average acceleration over a given interval according to a curve obtained in the velocity time graph corresponding to the rectilinear motion of a particle. This is a curve obtained in the velocity time graph. The curve is initially directed downward. Then it gets momentarily flat and finally is directed upward, and it is becoming steeper as time advances. Let's take a point capital T1 on the time axis. The corresponding time value is T1. Let's take another point capital T2 on the time axis, and the corresponding value of time is T2. Delta T is the corresponding interval. P1 is the point on the curve corresponding to point T1 on the time axis, and P2 is the point on the curve corresponding to point T2 on the time axis. V1 is the velocity corresponding to points P1 and T1, and V2 is the velocity corresponding to points P2 and T2. Let's draw a perpendicular from P1 to T2P2, and the perpendicular touches T2P2 at S. So T2S is V1 and T2P2 is V2. The join of P1 and P2 is the corresponding chord. The chord makes an angle theta with the positive time axis. P1S is delta T and SP2 is delta V. The average acceleration is the ratio of the change in the velocity to the interval over which the change in the velocity takes place, and is equal to delta V upon delta T, is equal to SP2 upon P1S according to the figure, is equal to the tangent of the angle theta. The tangent of angle theta is the slope of chord P1, P2. Hence we reach the definition of average acceleration in velocity time graph. The average acceleration over a given interval according to a curve obtained in the velocity time graph is equal to the slope of the corresponding chord. Now let's learn how to find the instantaneous acceleration in the velocity time graph. We have this curve in the velocity time graph. Capital T is a point on the time axis and small t is the corresponding time value. P is the point on the curve corresponding to point t on the time axis. The instantaneous acceleration is the instantaneous rate of change of the velocity with respect to time. It is the limit of delta V upon delta t as delta t tends to 0. Let's take another point t dashed very close to t on the time axis. T dashed is the corresponding time value. P dashed is the point on the curve corresponding to point t dashed on the time axis. The infinitesimal interval is delta t is equal to t dashed minus t, and delta t tends to 0. P dashed will be a chord simply not identifiable. Produced on both sides, P dashed will rather become the tangent drawn to the curve at point P. The tangent makes an angle theta with the positive time axis. Recollecting the definition of the average acceleration in the velocity time graph, we can define the instantaneous acceleration in the velocity time graph. Hence, the instantaneous acceleration corresponding to a point on the curve obtained in the velocity time graph is equal to the slope of the tangent drawn to the curve at that particular point.